May 27, 1941. 2:30 in the afternoon. Halfaya Pass, Egypt-Libya border. Captain Harold Harper, 31 years old from Surrey, commanded a troop of 4 Matilda II infantry tanks advancing up the rocky escarpment toward German positions. His tanks represented the best armor Britain could field in North Africa. Heavily armored, nearly impervious to most anti-tank weapons the Germans possessed. The Matilda's frontal armor measured 78mm thick, angled to deflect shots. German 37mm and 50mm anti-tank guns had proven almost useless against it. Intelligence reports indicated German defensive positions ahead held standard anti-tank weapons. Harper's orders were straightforward. Advance up the pass, destroy German guns, secure the high ground. His 4 tanks climbed the steep gradient in line formation, engines straining against the incline and the weight of their armor. Through his vision slit, Harper could see German positions approximately 800 meters ahead. He ordered his gunner prepare for engagement. Then the world exploded. The lead Matilda, commanded by Lieutenant Thomas Ridley, erupted in flames. Not the usual spark and smoke of a penetrating hit, but a massive explosion that tore completely through the tank's armor. The turret lifted off its mounting and tumbled down the slope. Secondary explosions followed as ammunition cooked off inside the hull. Harper screamed into his radio for the remaining tanks to reverse, to get behind cover, to do anything except continue advancing. The second Matilda took a hit before it could respond. The shell punched through the frontal armor, as though it were paper, not 78mm of hardened steel. The tank stopped instantly, smoke pouring from every hatch. Harper's own tank reversed frantically, tracks churning at the rocky ground. A third shell struck the hillside 10 meters to his left, throwing up a geyser of rock and sand. His driver managed to get the Matilda behind a low ridge just as another shell screamed overhead. 4 tanks had advanced. 2 were burning wrecks. 2 had escaped. The entire engagement had lasted perhaps 90 seconds. What Captain Harper didn't know, what British intelligence didn't know, what would take months of bitter experience to understand, was that he hadn't been engaged by anti-tank guns at all. He'd been engaged by 88mm Flak 36 anti-aircraft guns. Guns designed to shoot down bombers flying at 20,000 feet were being used horizontally against ground targets. The same guns that German crews had trained to track aircraft traveling 300 miles per hour were now tracking tanks traveling 15 miles per hour, an absurdly easy targeting problem by comparison. The 88mm shell, designed to explode and fragment among bomber formations, was instead punching to the thickest armor on any British tank in service. The kinetic energy of shell traveling nearly 3,000 feet per second, combined with a hardened armor-piercing core, meant there was essentially no British or American tank in 1941 that could survive a direct hit from an 88 at combat ranges. This weapon, this improvised use of anti-aircraft artillery against ground targets, would dominate North African battlefields for the next 2 years. It would force complete revision of Allied tank tactics and doctrine. It would earn legendary status among both German gunners who operated it and Allied tank crews who faced it. The Germans called it simply acht-acht, 88. Allied soldiers called it other names, most unprintable, all spoken with mixture of fear and grudging respect. This is the story of how an anti-aircraft gun became the most feared anti-tank weapon of World War II's North African campaign, and how one man's tactical innovation changed armored warfare forever. The 88mm Flak gun's development began in the 1920s when Germany, despite Versailles Treaty restrictions supposedly limiting military development, secretly worked with Swedish arms manufacturer Bofors and with Soviet Union to develop new weapon systems. The original design emerged from German military's analysis of World War I air warfare and predictions about future air threats. Military planners recognized that aircraft were becoming faster, flying higher, presenting increasingly difficult targets for existing anti-aircraft weapons. They needed a gun with high muzzle velocity capable of reaching aircraft at extreme altitudes with minimal time of flight. Krupp engineers, working initially under cover of various subterfuges to hide treaty violations, developed what would become the Flak 18 in the late 1920s. The designation 18 was deliberately misleading, suggesting the design dated from 1918, and thus predated Versailles restrictions. In reality, development occurred throughout the 1920s. The gun that emerged was remarkable for its time. The barrel measured just over 56 calibers in length, meaning the barrel was 56 times the diameter of the shell it fired. This extraordinary length gave the weapon tremendous muzzle velocity. A shell leaving the barrel traveled at approximately 840 meters per second, roughly 2,700 feet per second. The mounting allowed the gun to elevate to 85 degrees for anti-aircraft work and depress to -3 degrees. The traverse was 360 degrees. The gun could be aimed in any direction. The carriage design incorporated outriggers that extended when the gun was placed, providing a stable firing platform. For transport, these folded up and the entire weapon could be towed by a half-track or heavy truck. The ammunition was equally impressive. For anti-aircraft work, the standard round was a high-explosive shell with mechanical time fuse. The fuse was set before loading to explode at specific altitude, creating a fragmentation burst that would damage or destroy aircraft. The shell weighed approximately 20 pounds and contained nearly 2 pounds of explosive. But the ammunition that would make the 88 legendary against tanks was something else entirely: the armor-piercing round. This shell featured a hardened steel core designed to punch through armor plate. Unlike high-explosive shells that relied on blast effect, armor-piercing rounds relied purely on kinetic energy. The shell's weight and velocity combined to create penetrating power that could defeat any armor fielded in the early war years. The gun crew consisted of 11 men in standard configuration. Commander, 2 loaders who handled the heavy shells, 2 men operating the traverse and elevation mechanisms, a gunner who aimed and fired, a fuse setter for anti-aircraft rounds, and 4 ammunition handlers who kept shells moving from storage to the gun. A well-trained crew could maintain rate of fire approaching 15 to 20 rounds per minute under ideal conditions. Before we continue with how Erwin Rommel revolutionized the use of this anti-aircraft weapon and why British tank commanders reported shells that appeared from nowhere, destroying their armor. If you're fascinated by these stories of weapons used in ways their designers never intended, achieving devastating results through tactical innovation, subscribe and hit notification bell. We publish deeply researched military history documentaries every week that bring you the technological breakthroughs and tactical innovations that change warfare forever. Now back to 1940, and a gun that would earn a reputation as the most feared anti-tank weapon in the German arsenal. The 88mm Flak gun saw its first combat use during the Spanish Civil War beginning in 1936. Germany, supporting Francisco Franco's nationalist forces, deployed the Condor Legion, a German expeditionary force that provided air support, ground troops, and crucially, the opportunity to test new weapons under actual combat conditions. The 88mm guns deployed with Condor Legion served primarily in their intended anti-aircraft role. Republican forces, supported by Soviet Union, fielded various aircraft, including some relatively modern bombers and fighters. The 88s proved highly effective in this role, demonstrating their ability to engage aircraft at altitudes beyond the reach of smaller caliber anti-aircraft guns. But there were occasions, isolated incidents documented in Condor Legion after-action reports, where 88mm guns were used against ground targets. When Republican forces attacked positions where 88s were placed, German crews sometimes turned their guns horizontally and fired directly at attacking infantry or light vehicles. The results were devastating. The high explosive shells designed to fragment among aircraft formations proved equally effective against ground targets, and the psychological effect on troops being engaged by such heavy weapons was substantial. These incidents were not doctrine, not planned employment, simply expedient use of available weapons in desperate defensive situations. But they demonstrated something important. The 88mm gun could be effective against ground targets if the tactical situation required it. The invasion of Poland in September 1939 saw 88mm guns deployed primarily in anti-aircraft role, protecting German ground forces from Polish air attacks. Polish Air Force, though outmatched, continued fighting throughout the brief campaign. The 88mm batteries engaged Polish aircraft with considerable success. Again, there were isolated incidents of 88mm guns being used against ground fortifications. When German forces encountered particularly stubborn Polish defensive positions, especially fortified bunkers that resisted standard artillery, 88mm guns were occasionally employed for direct fire against these positions. The high velocity and large caliber made them effective bunker busters, though this was still considered an improvised use rather than standard doctrine. The invasion of France and Low Countries in May 1940 saw more systematic use of 88mm guns in both anti-aircraft and ground roles. The German Luftwaffe had achieved substantial air superiority, meaning the 88mm battery spent less time engaging aircraft and more time available for other uses. French defensive positions, particularly the pillboxes and fortifications of the Maginot Line extensions and field fortifications, sometimes required heavy weapons to reduce them. The 88mm guns proved capable of destroying these positions from ranges beyond the effective reach of French defensive weapons. German commanders began to recognize that the 88 had versatility beyond its primary anti-aircraft mission. It was during the French campaign that some German officers began explicitly considering the 88's potential as an anti-tank weapon. French heavy tanks, particularly the Char B-1 bis, had proven resistant to standard German anti-tank guns. The 37mm Pak-36, standard German anti-tank weapon, was essentially useless against the Char B-1's thick frontal armor. Even the newer 50mm Pak-38 struggled against heavily armored French tanks. But when 88mm guns engaged French tanks, whether accidentally during confused fighting or deliberately when other weapons had failed, the results were unambiguous. The 88mm armor-piercing round punched through French tank armor with ease. A single hit was usually catastrophic, often detonating ammunition or killing crew instantly. These experiences accumulated throughout 1939 and 1940, creating a body of combat knowledge about the 88's effectiveness against ground targets. But it took one particular officer's tactical vision to transform these isolated incidents into systematic doctrine. Erwin Rommel in early 1941 was already a legendary figure within German military, though not yet the international celebrity he would become. Born 1891 in Heidenheim, he had served with distinction in World War I, earning pour le Mérite, Imperial Germany's highest military decoration, for his actions during the Italian campaign. During the invasion of France in May 1940, Rommel commanded the 7th Panzer Division, which earned the nickname Ghost Division, for its rapid advances that often left German high command uncertain of its exact location. Rommel's aggressive leadership style, his habit of leading from the front, and his tactical creativity had brought him to Hitler's attention. In February 1941, when British Commonwealth forces threatened to drive Italian forces completely out of North Africa, Hitler decided to intervene. He selected Rommel to command what would become the Deutsches Afrikakorps, German Africa Corps. Rommel arrived in Tripoli, Libya, on February 12, 1941, with orders to prevent complete Italian collapse and stabilize the front. Rommel immediately recognized several critical factors about North African warfare that would shape his tactical thinking. First, the terrain favored mobile operations. The desert offered vast open spaces with few natural obstacles. Battles would be decided by maneuver and firepower rather than by holding fixed positions. Second, logistics would be decisive. Every shell, every liter of fuel, every spare part had to be shipped from Europe across the Mediterranean, then transported hundreds of miles across desert. Efficiency in logistics and ammunition use would determine operational capability. Third, British Commonwealth forces enjoyed substantial advantages in numbers and supply. Britain could draw on resources from across its empire and from increasing American aid. Germany would always be operating at the end of a long, vulnerable supply line. Rommel needed to achieve more with less, needed to find tactical advantages that could overcome material disadvantages. Fourth, tank warfare in the desert would be central to any campaign. The open terrain ideal for armored operations meant that whoever could destroy enemy tanks more effectively would control the battlefield. Erwin Rommel in early 1941 was already a legendary figure within German military, though not yet the international celebrity he would become. Born 1891 in Heidenheim, he had served with distinction in World War I, earning pour le Mérite, Imperial Germany's highest military decoration, for his actions during the Italian campaign. During the invasion of France in May 1940, Rommel commanded the 7th Panzer Division, which earned the nickname Ghost Division, for its rapid advances that often left German high command uncertain of its exact location. Rommel's aggressive leadership style, his habit of leading from the front, and his tactical creativity had brought him to Hitler's attention. In February 1941, when British Commonwealth forces threatened to drive Italian forces completely out of North Africa, Hitler decided to intervene. He selected Rommel to command what would become the Deutsches Afrikakorps, German Africa Corps. Rommel arrived in Tripoli, Libya, on February 12, 1941, with orders to prevent complete Italian collapse and stabilize the front. Rommel immediately recognized several critical factors about North African warfare that would shape his tactical thinking. First, the terrain favored mobile operations. The desert offered vast open spaces with few natural obstacles. Battles would be decided by maneuver and firepower rather than by holding fixed positions. Second, logistics would be decisive. Every shell, every liter of fuel, every spare part had to be shipped from Europe across the Mediterranean, then transported hundreds of miles across desert. Efficiency in logistics and ammunition use would determine operational capability. Third, British Commonwealth forces enjoyed substantial advantages in numbers and supply. Britain could draw on resources from across its empire and from increasing American aid. Germany would always be operating at the end of a long, vulnerable supply line. Rommel needed to achieve more with less, needed to find tactical advantages that could overcome material disadvantages. Fourth, tank warfare in the desert would be central to any campaign. The open terrain ideal for armored operations meant that whoever could destroy enemy tanks more effectively would control the battlefield. Rommel studied the weapons available to him. His Panzer III and Panzer IV tanks were reasonable machines but not dramatically superior to British tanks. His standard anti-tank guns, the 37mm Pak 36 and 50mm Pak 38, were adequate but not exceptional. British Matilda tanks with their heavy armor were particularly problematic. German tank guns and anti-tank guns often bounced harmlessly off Matilda armor. But Rommel had another weapon in his arsenal. As part of his combined arms force, Rommel's Afrika Korps included anti-aircraft batteries, equipped with 88mm Flak guns. These were intended to protect his ground forces from British air attack. The Royal Air Force maintained some presence over North Africa, and air defense was necessary. Rommel, drawing on his experience from the French campaign and on reports he'd read about 88mm's effectiveness against ground targets, began to consider systematic use of the 88 as an anti-tank weapon. The advantages were obvious to anyone who studied the specifications. The 88's muzzle velocity and armor penetration capability far exceeded any dedicated anti-tank gun in service with either side. If 88mm guns could be effectively employed against British tanks, they would provide Rommel with a weapon that could defeat any British armor at ranges where British tanks couldn't effectively return fire. But there were challenges to overcome. The 88 was not designed as an anti-tank gun. Its height, when in place, made it conspicuous and vulnerable to counter-battery fire. Its size and weight made it less mobile than dedicated anti-tank weapons. Crews were trained for anti-aircraft work, not ground combat. Doctrine and training would need to be developed for a mission the weapon wasn't designed for. Rommel, characteristically, didn't wait for official doctrine or formal training programs. He began experimenting with 88mm's employment against ground targets immediately upon arriving in North Africa. Rommel's first offensive operations in North Africa began in late March 1941. Despite orders from German High Command to remain on defensive until his forces were fully assembled and supplied, Rommel attacked. He recognized that British forces facing him were overextended and vulnerable. Waiting would only allow them to consolidate. The offensive that began March 24, 1941, saw Rommel's forces advancing rapidly eastward from their positions around El Agheila. British Commonwealth forces, surprised by German aggression they hadn't anticipated, began withdrawing to avoid being cut off. During these initial advances, Rommel had opportunities to test his theories about 88mm's employment against armor. At several engagements during the advance, 88mm guns that had been positioned as anti-aircraft defense were turned against British tanks when the tactical situation allowed. The results confirmed what Rommel had suspected. British cruiser tanks, the fast medium tanks that formed the backbone of British armored formations, had no chance against 88mm's fire. The shells punched through their armor with ease. Even the heavily armored Matilda infantry tanks, which had proven nearly invulnerable to German tank guns and standard anti-tank weapons, could be destroyed by 88mm's hits. British tank commanders reported facing weapon fire that seemed impossibly powerful. Shells arrived with flat trajectories that suggested high-velocity weapons, but the impacts had explosive force beyond what anti-tank guns normally produced. The penetrations were massive. Not the neat holes that anti-tank rounds typically created, but enormous punctures that often killed entire crews and detonated ammunition. Intelligence officers struggled to understand what weapon was being used. The obvious answer, that Germans were using anti-aircraft guns against tanks, seemed almost too absurd to credit. Why would anyone use a huge, conspicuous anti-aircraft gun when dedicated anti-tank weapons existed? But the evidence accumulated. British forces that overran German positions found 88mm gun emplacements with expended shell casings, positioned not for anti-aircraft fire, but for direct ground fire with clear fields of view across tank approaches. Interrogation of captured German gunners confirmed that they were anti-aircraft specialists who had been ordered to engage ground targets. By mid-April 1941, British commanders recognized they faced a new threat. The 88mm gun, employed in anti-tank role, was more dangerous than any other weapon in Rommel's arsenal. Rommel didn't simply order his 88mm batteries to shoot at tanks. He developed specific tactical employment methods that maximize a weapon's advantages while minimizing its considerable disadvantages. The most critical innovation was the use of 88mm guns in carefully prepared defensive positions rather than mobile offensive use. The gun size and weight made it ill-suited for rapid deployment during fluid battles. But when placed in prepared positions with good fields of fire, camouflaged and protected, the 88 became nearly unstoppable. Rommel's typical defensive scheme placed 88mm guns in depth, creating multiple defensive belts. The forward positions would be held by infantry with standard anti-tank guns and mines. These weren't expected to stop British tank attacks, but to channel them, slow them, force them to concentrate. Behind this forward screen, at ranges of 1,000 to 1,500 meters, Rommel positioned his 88mm guns in carefully camouflaged positions. The guns were dug in to reduce their silhouette. Gun crews constructed berms and revetments to protect the weapons and personnel. Camouflage netting and local materials disguised the positions. Most critically, Rommel insisted on firing discipline. The 88s were not open fire at maximum range, but to hold fire until British tanks had committed to their attack, had moved well into the killing zone, where multiple 88s could engage simultaneously, and where British tanks would find it difficult to rapidly withdraw. The effect was devastating. British tank formations would advance against what appeared to be standard German defensive positions. They would engage forward German positions, perhaps destroying some anti-tank guns and infantry positions. As they pressed forward, confident they were winning the engagement, suddenly massive hits would begin tearing through their tanks from positions they hadn't even known existed. By the time British commanders realized they were being engaged by 88mm guns, their tanks would be well into the killing zone with limited options for maneuvering to safety. The flat desert terrain that was ideal for tank operations also meant there was often limited cover to hide behind. Tanks trying to withdraw would be moving away from the 88 positions, presenting their thinner rear armor. The psychological effect compounded the physical destruction. Tank crews who had felt relatively safe behind their armor, confident that German anti-tank guns couldn't seriously threaten them, discovered they were vulnerable to weapons they couldn't effectively engage. The 88's long range meant it could destroy British tanks from positions beyond effective return fire range of British tank guns. Rommel also developed a tactic of using his panzers as bait. German tanks would engage British forces, then execute fighting withdrawal that would draw British tanks toward prepared 88mm positions. British commanders, thinking they were pursuing defeated Germans, would advance directly into killing zones. The coordination required for this was substantial. German tank commanders had to know exactly where the 88 positions were to avoid drawing fire themselves. Communications had to be maintained between armor and anti-aircraft units. Timing had to be precise. If the 88s opened fire too early, British tanks might recognize the trap and withdraw. Too late, and German tanks might be caught in the crossfire. Rommel personally supervised many of these ambush operations, positioning himself where he could observe the entire battlefield and coordinate the complex choreography of bait, pursuit, and annihilation. British forces, having been driven back to the Egyptian border by Rommel's March-April offensive, prepared a counteroffensive to relieve the besieged garrison at Tobruk and drive German forces out of Cyrenaica. The operation, codenamed Battleaxe, was intended to demonstrate British armor superiority and defeat Rommel decisively. General Archibald Wavell, commanding British forces in the Middle East, assembled a substantial force for the operation. The Western Desert Force, recently renamed 13 Corps, included 2 armored divisions with over 200 tanks and substantial infantry support. British planners expected the offensive to succeed through weight of numbers and aggressive armored action. The offensive launched June 15, 1941, with British forces advancing on multiple axes toward German positions. The initial attacks achieved some success. British tanks overran forward German positions, destroyed some anti-tank guns, and appeared to be making progress. Then they encountered Rommel's 88mm defensive belt. The engagement at Halfaya Pass became legendary for demonstrating the 88's devastating effectiveness. Rommel had fortified the pass, a critical route through the escarpment, separating the coastal plain from the desert plateau, with multiple 88mm positions dug in with excellent fields of fire commanding the approaches. British tanks advancing up the pass found themselves trapped in a killing zone. The narrow confines of the pass limited their ability to maneuver. The 88mm guns, positioned to enfilade the approach routes, destroyed tank after tank with methodical precision. Captain Miles, commanding a squadron of cruiser tanks, reported that his unit lost 11 tanks to 88mm fire in less than 20 minutes. The guns were so well camouflaged that British tankers couldn't spot them until after they'd opened fire. Return fire from British tanks was ineffective. The 88 positions were either too well protected or beyond effective range of British tank guns. The engagement at Halford Ridge showed similar pattern. British Matilda tanks, confident in their heavy armor, advanced against German positions. The 88mm guns opened fire at approximately 1,200 meters, well beyond the effective range of British 2-pounder tank guns. Matilda after Matilda exploded or burned as 88mm shells punched through armor that had been considered nearly invulnerable. Over 3 days of fighting, Operation Battleaxe deteriorated into a British defeat. Of the roughly 200 tanks committed to the offensive, British forces lost 91 tanks destroyed or captured. Many of these losses came from 88mm fire. German losses included 12 tanks. The disparity stunned British commanders. How had German forces, numerically inferior, achieved such decisive victory? The answer lay substantially with the 88mm guns employed in anti-tank role, according to Rommel's tactical doctrine. British after-action reports noted that German defense in depth, combined with deadly effectiveness of 88mm guns, had created a defensive system that British tactics and equipment couldn't overcome. Frontal assaults against repaired 88mm positions resulted in catastrophic losses. Attempting to bypass these positions often meant exposing British tanks to enfilade fire. Wavell's report to London concluded that British forces needed either new tactics or new weapons to deal with the 88mm threat, preferably both. The defeat led directly to Wavell's replacement by General Claude Anlec. British military intelligence struggled throughout 1941 to understand exactly what weapon was causing such devastating tank losses. Early reports identified the gun as 88mm cannon, without clearly understanding it was an anti-aircraft weapon being used in ground role. Some intelligence assessments theorized that Germans had developed a new super-heavy anti-tank gun specifically for North Africa. This seemed more plausible than reality that Germans were improvising with anti-aircraft weapons. Surely if a dedicated 88mm anti-tank gun existed, it would be mentioned in German documents, training manuals, or interrogations of prisoners. The confusion was understandable. From British tankers' perspective, being engaged by 88mm fire didn't feel like being engaged by anti-aircraft gun. There was no visible difference between dedicated anti-tank gun and anti-aircraft gun when both were firing the same ammunition at ground targets. The shell arrived, punched through armor, killed crew. The launching platform was irrelevant to men dying and burning tanks. Captured German gun emplacements provided physical evidence that these were indeed Flak 36 anti-aircraft guns, but British analysts initially struggled to accept that this was systematic doctrine rather than desperate improvisation. Surely using anti-aircraft guns against tanks was an expedient necessitated by shortage of proper anti-tank weapons? Interrogation of captured German gunners revealed truth. They were anti-aircraft specialists who had received training in ground engagement. They described tactical doctrine, camouflage procedures, engagement parameters, all indicating this was systematic employment, not improvisation. By late 1941, British intelligence had accepted reality. Germans were deliberately using 88mm anti-aircraft guns as anti-tank weapons, and doing so with devastating effectiveness. This recognition prompted several responses. First, tactical adaptation. British armor commanders adjusted their approach to attacking German positions. Frontal assaults were avoided when possible. British forces attempted to develop methods for locating 88mm positions before committing tanks to attack. Artillery and air strikes were used to suppress suspected 88 positions before tank advances. Reconnaissance became more sophisticated. British forces used light tanks and armored cars to probe German positions, attempting to draw fire that would reveal 88 locations without committing heavy tanks. This worked sometimes, but German gun crews were disciplined about holding fire until valuable targets presented themselves. Infantry tank coordination improved. British doctrine increasingly emphasized combined arms operations where infantry would assault defensive positions, while tanks provided mobile fire support rather than leading assaults against prepared positions. Second, equipment response. British weapons development began focusing on guns that could engage targets at ranges comparable to the 88. The 17-pounder anti-tank gun, entering development in 1941, was specifically designed to match or exceed 88mm performance. But development and production would take time. British forces in North Africa through 1942 would continue facing 88mm guns with equipment inadequate to counter them at range. Tank design began incorporating lessons learned. Thicker armor, better gun, improved optics, all reflect the recognition that British tanks needed to either survive 88mm hits or destroy 88mm positions before they could fire. The former proved impossible with existing technology. The latter remained difficult given the 88's long range and German tactical employment. Third, psychological adjustment. British tank crews had to overcome fear of weapons that could destroy their vehicles from ranges where they couldn't effectively fight back. This required changes in training, leadership, and operational doctrine. Tank commanders learned to avoid situations that would expose them to 88mm fire from prepared positions. But despite these adaptations through all of 1942, British forces continued to struggle against 88mm equipped German defenses. The weapon, combined with Rommel's tactical skill, provided Germany with qualitative advantage that partially offset British quantitative superiority. The 88mm Flak 36 gun could penetrate approximately 110mm of vertical armor plate at 1,000 meters range when firing armor-piercing ammunition. At 500 meters, penetration increased to approximately 130mm. These figures represented capability against homogeneous rolled armor plate perpendicular to the shell's trajectory. In practical terms, against actual tank armor at realistic engagement angles, the 88 could defeat any British tank in North Africa through 1942. The Matilda II 78mm of frontal armor offered no protection. The Crusaders' 51mm frontal armor was hopelessly inadequate. Even the American-supplied Grant tank, arriving in mid-1942 with better armor and armament than previous British tanks, could be penetrated by 88mm fire at normal combat ranges. The effective anti-tank range for 88mm gun was approximately 2,000 to 2,500 meters under ideal conditions. At this range, experienced gunners could achieve high hit probability against tank-sized targets, and penetration remained sufficient to defeat available armor. Practical engagement ranges were often shorter, typically 1,000 to 1,500 meters, where hit probability increased and where tactical situations often developed. The gun's high muzzle velocity meant flat trajectory and minimal time of flight. A shell fired at 1,000 meters reached target in approximately 1.5 seconds. This gave minimal warning and made evasive maneuvering difficult. By the time a tank crew saw the muzzle flash, the shell was already arriving. Rate of fire depended on crew training and tactical situation. Theoretical maximum with well-trained crew was 15 to 20 rounds per minute. Practical sustain rate was closer to 8 to 12 rounds per minute. Each round required loading an approximately 20-pound shell, closing the breech, aiming, firing, ejecting the casing, then repeating. The physical demands were substantial, and crews fatigued quickly in the North African heat. Ammunition supply was critical constraint. Each 88mm gun position would typically have 100 to 200 rounds immediately available in the position. Additional ammunition would be stored nearby, but required time to bring forward. In prolonged engagement, ammunition expenditure could be substantial. A gun engaging multiple targets over an hour could easily fire 50 to 100 rounds. The weapon's major limitation was its visibility and vulnerability. Even when dug in camouflage, the 88 was a large target approximately 6 meters wide with the outriggers deployed, standing roughly 2.5 meters high even when dug into a pit. Compared to dedicated anti-tank guns that might be only 1 meter high, the 88 was conspicuous. Once an 88 position revealed itself by firing, it became priority target for British artillery and air attack. The gun itself was relatively fragile. No armor protection for crew or mechanism. Artillery near misses could damage the weapon or kill crew. Air attack was particularly dangerous, as the 88 size made it relatively easy target for dive bombing or strafing. Mobility was another significant limitation. Moving an 88 from one position to another required substantial time and effort. The gun had to be disconnected from its outriggers, lifted onto its wheeled carriage, hitched to a prime mover, towed to new position unhitched, set up with outriggers deployed, leveled, and camouflaged. This process took well-trained crew minimum 30 to 45 minutes under ideal conditions. In fluid battle situations where positions were constantly changing, this immobility was serious handicap. The 88 was a weapon that excelled in prepared defensive positions, not in mobile warfare. Rommel's tactical genius lay partly in recognizing this limitation and developing operational methods that played to the weapon's strengths while minimizing its weaknesses. By October 1942, the strategic situation in North Africa had evolved significantly. Rommel's furthest advance into Egypt had been stopped at First Battle of El Alamein in July. Both sides had reinforced and prepared for decisive engagement. The British Eighth Army under new commander General Bernard Montgomery had received substantial reinforcements, including new American Sherman tanks with better armor and guns than previous British tanks. Montgomery also benefited from ultra-intelligence, decrypted German communications that provided detailed information about Rommel's dispositions, supply situation, and plans. Rommel's forces, by contrast, were at the end of impossibly long supply lines stretching from Germany to Italy across Mediterranean to North African ports, then across hundreds of miles of desert. Fuel shortages, ammunition shortages, and equipment shortages plagued German and Italian forces. Many German tanks were not operational due to lack of spare parts. Italian units were poorly equipped and of variable quality. Rommel's defensive line at El Alamein stretched approximately 40 miles from Mediterranean coast south into Qatar Depression. The position was strong. Flanks secured by natural obstacles, depth organized in defensive belts with extensive minefields, wire obstacles, and prepared positions. The 88mm guns formed critical component of this defense. Rommel positioned as available 88s in depth throughout the defensive system, creating multiple killing zones that British tanks would have to cross during any breakthrough attempt. Some 88s were positioned in forward areas to engage initial British assaults. Others were held in reserve positions to counterattack any British penetrations. Montgomery's plan for 2nd El Alamein recognized the 88mm threat explicitly. Rather than the armored thrust that had characterized previous British offensives, Montgomery planned methodical infantry assault supported by overwhelming artillery. Infantry would create breaches in German minefields and defensive positions. Armor would exploit these breaches, but only after German anti-tank defenses had been suppressed. The battle opened on night of October 23, 1942, with massive British artillery barrage. Over 1,000 guns fired on German positions. The bombardment was intended to destroy or suppress German artillery and anti-tank guns, including 88mm positions. The artillery barrage achieved mixed results against 88mm positions. Some guns were destroyed or damaged by direct hits. Many crews were shaken by the intensity of fire, but well-constructed German positions protected many guns, and experienced crews weathered the bombardment then returned to action. When British infantry began advancing through gaps and minefields, German defensive fire, including 88mm guns firing high explosive shells against infantry targets, caused significant casualties. The 88's anti-personnel effectiveness was substantial. Each high explosive shell created deadly fragmentation pattern over wide area. As British forces created breaches in forward German positions, British armor began moving through gaps. They immediately encountered 88mm fire from surviving German positions. Despite Montgomery's methodical approach, British tanks still had to cross open ground under 88mm fire, and losses mounted. The fighting continued for nearly 2 weeks. Montgomery's superior numbers and logistics allowed him to sustain offensive despite casualties. German forces, low on fuel and ammunition, couldn't effectively counterattack or reinforce threatened positions. Gradually, British forces ground through German defenses. The 88mm guns fought to the end. Many positions were overrun only after crews had exhausted ammunition or been killed. Some guns were evacuated during the German retreat that followed British breakthrough. Many were destroyed by their crews or captured when German fuel shortages left them stranded. 2nd El Alamein represented turning point in North African campaign. After this battle, German forces would be in continuous retreat westward, but the 88mm gun remained dangerous even in defeat. During the long retreat across Libya, German rearguard actions frequently centered on 88mm positions that delayed British pursuit and inflicted casualties before withdrawing. The Tunisia campaign from November 1942 through May 1943 saw a final confrontation in North Africa. Allied forces advancing from east, British Eighth Army pursuing Rommel, and from west, American and British forces landed in Operation Torch, converged on German-Italian bridgehead in Tunisia. The mountainous terrain of Tunisia differed dramatically from open desert that had characterized earlier fighting. Narrow valleys, ridges, mountain passes create constrained battle space where maneuver was limited. This terrain favored defensive operations and played to 88mm gun strengths. German forces, though being compressed into ever-shrinking perimeter, continued to employ 88mm guns with devastating effectiveness. Every Allied attempt to break through German defensive lines encountered 88mm fire. The guns were positioned to cover critical terrain, passes, valleys, approaches to important positions, creating interlocking fields of fire that channeled Allied attacks into killing zones. The Battle of Kasserine Pass in February 1943 demonstrated that Americans, new to North African combat, had much to learn about the 88mm threat. American armor advancing through the pass encountered German defensive positions, including 88mm guns. The results were catastrophic. American tanks destroyed in large numbers, American infantry routed. Substantial territorial losses before Allied forces stabilized the situation. American after-action reports from Kasserine noted same observations British had made in 1941. Difficulty spotting 88mm positions before they fired. Devastating effect of 88mm fire on American tanks. Psychological impact of facing weapon that could destroy tanks from ranges where American tanks couldn't effectively return fire. As Tunisia campaign progressed through spring 1943, Allied forces developed more effective methods for dealing with 88mm positions. Overwhelming artillery support suppressed German positions before tank advances. Air superiority allowed Allied aircraft to attack German positions, including 88mm emplacements. Superior numbers and logistics allowed Allied forces to sustain offensive despite casualties. But individual 88mm guns remained deadly until the end. The final battles around Tunis in May 1943 saw German forces defending desperately shrinking perimeter. 88mm guns formed backbone of these defenses, fighting until overrun or out of ammunition. When German resistance in Tunisia ended May 13, 1943, with surrender of remaining Axis forces, Allied forces captured many 88mm guns along with their crews. Intelligence officers interviewed captured gunners, examined the weapons, documented tactical employment. The information confirmed what Allied forces had learned through bitter experience over 2 years. The 88mm was extraordinarily effective anti-tank weapon when properly employed. While North Africa showcased the 88mm gun's anti-tank capabilities most dramatically, the weapon played equally important role in European theater after Allied invasion of Normandy in June 1944. German defensive preparations in France included emplacement of 88mm guns in carefully prepared positions covering likely invasion beaches and approaches inland. These guns served dual purpose: anti-aircraft defense against Allied air forces and anti-tank defense against anticipated Allied armor forces. When Allied forces landed on D-Day, June 6, 1944, some beaches encountered 88mm fire. The guns engaged landing craft and vehicles coming ashore, causing casualties and destruction. But Allied overwhelming firepower, naval gunfire, air support, sheer numbers, suppressed or destroyed many 88mm positions during initial assault. In the fighting inland from beaches, Allied armor regularly encountered 88mm positions. German defensive doctrine in Normandy blockage, country positioned 88mm guns to cover roads, open fields, approaches to villages, anywhere Allied tanks might advance. The hedgerows and close terrain of Normandy made it difficult for Allied forces to spot 88mm positions until they came under fire. American tankers reported that 88mm fire was one of the most feared threats in Normandy. The sound of an 88 firing, distinctive sharp crack, caused immediate panic and evasive maneuvering. Many tank crews who survived 88mm hits described the experience as terrifying, sudden massive impact, shell punching through armor, catastrophic secondary effects inside the tank. British and Canadian forces pushing south from their landing beaches encountered similar experiences. German defensive positions around can included numerous 88mm guns that made Allied armored operations costly. Operation Goodwood in mid-July 1944, massive British armored assault intended to break out from Bridgehead, encountered prepared German defenses with 88mm guns positioned in depth. British lost over 300 tanks in the operation, many to 88mm fire. As Allied forces broke out from Normandy and began rapid advance across France, the 88mm's mobility limitations became more apparent. German forces in retreat couldn't always evacuate their 88mm guns before Allied advances overran positions. Many guns were captured or destroyed by their crews to prevent capture. But even in retreat, German rearguard actions frequently centered on 88mm positions that delayed Allied pursuit. A single 88mm gun in good position could hold up Allied armored column for hours, destroying lead vehicles and forcing Allies to deploy artillery and infantry to eliminate the position. The original Flak 18 and Flak 36 guns that dominated North African fighting were supplemented and eventually partially replaced by improved variants as the war progressed. The Flak 37, introduced in 1939, incorporated various improvements over Flak 36, including better fire control instruments and electrical systems. Externally nearly identical to Flak 36, the Flak 37's improvements were largely internal. Better gun-laying mechanisms, improved sighting systems, enhanced training of fire control calculators. The Flak 41, entering service in 1943, represented more substantial redesign. The barrel was lengthened to 74 calibers compared to 56 calibers on Flak 36, increasing muzzle velocity to approximately 1,000 meters per second. The higher velocity improved both anti-aircraft capability and armor penetration. At 1,000 meters, Flak 41 could penetrate approximately 190 millimeters of armor, substantially more than Flak 36. However, Flak 41 suffered from various mechanical problems and was produced in limited numbers. The longer barrel created greater stress on the mechanism, leading to accelerated wear. The weapon was more complex and expensive to manufacture than Flak 36. Most German 88mm batteries continued using Flak 36 or Flak 37 through the end of the war. The Pak 43, introduced 1943, represented a deliberate redesign of 88mm concept specifically as anti-tank weapon rather than anti-aircraft gun adapted to ground roll. The Pak 43 used similar ballistics to Flak 41, but mounted on purpose-designed anti-tank gun carriage. Lower silhouette, better mobility, specifically optimized for anti-tank roll. Pak 43 could penetrate over 200 millimeters of armor at 1,000 meters, sufficient to defeat any Allied tank, including heavily armored types like Soviet IS-2 or British Churchill. But like Flak 41, Pak 43 was complex and expensive, produced in limited numbers. The 88mm gun also found application in tank destroyer vehicles. The Ferdinand/Elephant heavy tank destroyer mounted Pak 43 in fixed superstructure on Tiger tank chassis. The Nashorn mounted Pak 43 on Panzer IV chassis with open top fighting compartment. The Jag Panther, one of the most effective tank destroyers of the war, mounted Pak 43 in sloped armor superstructure on Panther chassis. These self-propelled variants address some mobility limitations of towed 88mm guns while retaining the weapon's devastating firepower. But they were produced in relatively small numbers, hundreds rather than thousands, and couldn't fully replace towed 88mm guns that continued serving through war's end. Allied post-war analysis of German weapon systems consistently rated 88mm gun as one of the most effective weapons fielded by any combatant during World War II. British and American after-action reports noted that 88mm gun had influenced tactical doctrine, shaped weapons development, and forced adaptation of combat methods. Statistics documented 88mm effectiveness. Various studies attempted to calculate how many Allied tanks were destroyed by 88mm guns, but exact numbers remained elusive. Battlefield conditions made attribution difficult. Was tank destroyed by 88mm gun, by German tank, by mine, by other anti-tank weapon? Many tanks were hit by multiple weapons or circumstances of loss were unclear. Conservative estimates suggested 88mm guns destroyed several thousand Allied tanks during the war. More liberal estimates reached 5,000 or more. Given total Allied tank losses on all fronts exceeded 50,000 vehicles, 88mm guns likely accounted for a significant minority of total losses, perhaps 10 to 20%. More important than raw numbers was psychological impact. Allied tankers feared 88mm fire more than any other anti-tank weapon. The gun's long range, high velocity, and devastating effect created psychological effect beyond its actual kill numbers. Tank crews operated knowing that somewhere ahead might be 88mm gun they couldn't spot until it fired, that could destroy their tank with single hit. This fear influenced tactical decisions. Allied armor commanders avoided situations where 88mm fire was likely. They devoted substantial resources to locating and suppressing 88mm positions before committing tanks. They developed entire tactical systems centered on minimizing exposure to 88mm fire. From German perspective, 88mm gun represented a rare success story in war, where they were increasingly outproduced and outnumbered. The gun provided qualitative advantage that partially offset quantitative disadvantages. A single 88mm gun in good position could destroy multiple Allied tanks, could hold up Allied advance, could make difference between successful defense and breakthrough. German veterans consistently identified 88mm gun as one of the most valuable weapons they possessed. Accounts from panzer commanders, infantry officers, gunners themselves emphasized the gun's reliability, effectiveness, and importance of German defensive operations. Many 88mm guns survived the war and entered museum collections worldwide. The weapon's historical significance ensured that examples were preserved for future study. Major military museums in Germany, Britain, United States, and other nations maintain 88mm guns in their collections. Some examples are displayed in original configuration on their towed carriages with outriggers. Others show the weapon in firing position, dug in as they would have been in combat. A few museums have reconstructed defensive positions showing how 88mm guns were integrated into larger defensive systems. Veterans organizations and historical societies have worked to preserve 88mm guns and document their history. Surviving veterans, both German gunners who operated the weapons and Allied soldiers who faced them, provided oral histories and documentation. These first-hand accounts became increasingly valuable as the veteran generation passed away. Several 88mm guns have been restored to firing condition for historical demonstrations. These carefully supervised firings, typically at special events or for documentary filming, allow modern audiences to appreciate the weapon's sound and power. The distinctive crack of an 88mm firing, the visible muzzle blast, the field concussion, these visceral elements bring the weapon's history alive in ways static museum displays cannot. British tanks never expected anti-aircraft guns at ground level because such employment violated conventional wisdom about weapon specialization. Anti-aircraft guns were designed to shoot down aircraft. Anti-tank guns were designed to destroy tanks. Mixing the roles seemed inefficient, seemed like desperate improvisation rather than sound doctrine. The 88mm gun proved that weapon versatility could be decisive advantage. A gun that can gauge aircraft at 20,000 feet could also destroy tanks at 2,000 meters. The same high velocity that reached bombers could penetrate armor. The same flat trajectory that minimized time of flight against aircraft minimized lead requirements against ground targets. Rommel recognized this potential and developed doctrine to exploit it. He positioned 88mm guns in defensive depth. He used combined arms tactics to draw Allied armor into killing zones. He insisted on camouflage and fire discipline that maximized surprise. He created a tactical system where obsolete anti-aircraft gun became most feared anti-tank weapon on battlefield. The 88mm's dominance forced Allied adaptation. British and American forces developed new tactics, new weapons, new operational methods to counter the threat. The 17-pounder gun, the 76mm gun, the 90mm gun, all represented responses to 88mm challenge. Tank destroyer doctrine, infantry armor coordination, artillery suppression, all reflected lessons learned facing 88mm fire. For nearly 4 years from 1941 through 1944, the 88mm gun provided Germany with qualitative advantage in anti-tank warfare that partially offset Allied quantitative superiority. A weapon designed to defend Reich from strategic bombing became instead the weapon that defended Rommel's panzers from Allied armor. 20,000 guns produced, thousands of Allied tanks destroyed, millions of rounds fired. The 88mm Flak gun, pressed into service against ground targets, proved that sometimes the most effective weapon is the one used in ways its designers never imagined. Acht-acht, 88, the gun British tankers learned to fear. The gun Rommel used to dominate North African battlefield. The gun that demonstrated technology alone doesn't determine victory. Tactical innovation, operational creativity, and willingness to challenge assumptions mattered just as much. From Halfaya Pass to Tunisia, from Normandy to Berlin, the distinctive crack of an 88mm firing meant Allied tankers faced weapon that could destroy them from ranges where they couldn't fight back. That sound, that threat, shaped battlefield behavior and tactical decisions for entire war. The gun Germany designed to shoot down bombers became the gun that stopped Allied tanks, not through accident, not through desperation, but through innovation, through tactical vision, through recognition that weapons have potential beyond their original design, potential that creative commanders can unlock and exploit.